Okay, this is section 6.2 in your textbook, 274. We're talking about quadratics again, of course, and we're learning out how to solve them. So solve quadratic equations. Someone like to read the first little blurb there? Flight path of a toy rocket. Arik, yeah, please aloud.
The flight path of a toy rocket, a ball, or any projectile can be predicted using a quadratic model. This model can also be used to determine when and where a projectile will land. For example, the path of a stone thrown in a ravine is modeled by the quadratic relation y equals negative x squared plus 5x plus 8 squared, where x is the distance in meters it travels horizontally and y is the height in meters above the river at the bottom of the ravine. You can solve for x using a variety of methods, including factoring a quadratic equation.
Okay, good. So these type of equations, guys, it's ax squared plus bx plus c, x squared plus 9x plus 14. All of these equations, as you've already seen in some of your tests, they basically model this parabola shape. Okay, and as you've seen before, we talked about a football being thrown or a pebble being thrown or any sort of object that's being thrown in the air. If it is an object being thrown in the air, remember that your x value or your a value in front of your x squared is always going to be negative because it's opening down in that case. Okay? Opening up would be some sort of other model that you could think of, maybe something underwater, so going underwater and then coming to the surface. So it's maybe a person diving in the water and then coming up. Okay? But all of these projectile type questions have a negative a value. Okay, so quadratic equation, what is it? It's an equation in the form ax squared plus bx plus c, where a, b, and c are real numbers being any number that we know of at this point. And a cannot be 0, because the reason why, if a is 0, then we don't have a square term, right? So a quadratic, really the short definition is that the degree is 2, okay? Or in other words, the highest exponent for the equation is 2. Right, so that's what we're looking for. The root of an equation. So I think we've talked about this terminology before. The root, it's the value of the variable that makes an equation true, the same as a solution for an equation. So all of these are kind of synonyms. Roots, solutions, zeros, and x-intercepts. They're all talking about the same thing here, okay? All right, so if we want to solve by factoring these equations, we're going to use what we've learned in the past. Okay, for this particular example, what would be done, Mike?
You have to set one of the equations to 0.
Right, so if we were just factoring, guys, we'd be done at this point, but we're not. It says solve, okay? If it said factor, there you've done, you're factored. But it says solve, so in order to solve, we need to find a value of x. So this equation is equal to 0. This factored equation is still equal to 0. Now we spoke about this before where now each one of these two binomials have to equal 0. So we're going to consider both of them. So x plus 7 is equal to 0, and x plus 2 is equal to 0. So x is equal to negative 7, and x is equal to negative 2. Now, we are done. Or are we done? Is there anything else we can do to verify we're correct here in this case? So if I said solve by factoring plus verify, how would I verify that I'm right? Sebastian, what do you think? Can you put your legs down, please? I'm sorry, explain to me what we did.
Foil.
Foil. If we foil, we'll get back to here. So you wouldn't want to foil, Nicholas?
Can't you just plug it into the equation?
Right, so you would take this value and plug it in, and take this value. Both of them should give us 0. So we're going to do left-hand side. Left-hand side. So left-hand side is negative 7 squared plus 9 times negative 7 plus 14. If we work this out, we'll get 0. Our right side is also 0. So because these two are the same, negative 7 is a root of this equation. Yeah, Julius?
Wouldn't it be easier to plug it into the second line?
The negative 2?
Yeah, into the x plus 7 and x plus 2.
Yeah, but if you factored it wrong, then you're just verifying your error. Okay, so yeah, you're right, it would be easier, but you always want to go back to the very original equation. Okay, and the reason why is because you could have made a mistake from here to here. Okay, that's why. And then you do the same thing for the second value of x. So we have -2 squared plus 9 times -2 plus 14. So we get 4 minus 18 plus 14 is equal to 0. So that's my left-hand side, and that's my right-hand side. 0 and 0. Okay, so now we've factored, we've set equal to 0. So some people might say when we get to this point, we can say that, well, I know the values are just the opposite sign. My only word of caution to you then is be careful. If there's a coefficient of x, that method won't work. Okay, if you just say the values are x equals -7, x equals -2. So that's why I do this extra step, because if there's a coefficient here, you need to factor that in. Okay, so consider that. All right, next one. So we're missing a c value here, so it still says solve by factoring. So when we're factoring this, we're going to take out the greatest common factor between these two terms. All right, in this case it's x. So we're left with 2x plus 5. And believe it or not, that's it. You're done. Okay, you cannot factor it anymore. It's fully factored. Now you're going to set both sides equal to 0. Even though this is just x, you still have to set this term, because if x is 0, then it doesn't matter what this is. It's going to satisfy this equation. That's why x can be equal to 0, so that's one scenario. The other scenario is 2x plus 5 is equal to 0. So 2x equal to -5, x is equal to -5/2. Okay, so you need to consider still x is 0 or this binomial is 0. If you have a question, ask up here, guys. Yeah.
So when we do this, like on a test or something, do we have to show you the left side, right side for checking?
If it says verify, you do, yeah. If it doesn't say verify, you don't. But it doesn't hurt to do, right? It doesn't take a long time. So x is equal to 0, I plug it in here. This is 0, this is 0. 0 plus 0 is 0. Left side and right side are the same, right? So left side, I'm going to plug in 0. This is going to be equal to the right side, right? 0 equals 0. Yeah, all right.
So when you're doing something like that, you just take what's outside the bracket, what's inside the bracket, and you make it to left side, right side?
No, you take this whole thing as the left side. This is the right side. So this whole thing is left side. See how I subbed in -7 into each x value here? Okay? So left side, right side is the brackets aren't even existing yet. Left side is from the original equation. Okay? And right side is always 0, usually, typically, right? In this case it's not, but we're going to rearrange it so it is, but either way. Okay? So when you do left side, right side, you always look at the original equation. Okay? And again, that's because if you might make a mistake along the way. Yeah?
So for me, how did you get 5 over 2? If you put the 0 on the x on the left side to 0, then everything's 0, right? Because you're multiplying.
So how did I get this one?
Yeah.
All right, so 2x plus 5 is equal to 0. You okay with that line?
Oh, if x is 0 outside the brackets, wouldn't everything be 0?
Okay, yeah, there's two scenarios, right? So the one scenario, like here, see we had to check x plus 7 is equal to 0. Here we're checking just x is equal to 0. X is equal to 0, x is 0. That's one solution.
Okay.
So x is equal to 0 is one of the roots. Okay? But the other one is if this is 0. Let's say x is not equal to 0, but this is. If this 2x plus 5, this binomial is 0, the whole expression will be true, right?
But so yeah, my question is, if 2x was 0, wouldn't that entire term be 0? And would you just be left with positive 5?
If 2x was 0,
Yeah.
you're left with 5 equals 0, which doesn't make any sense. I'm not sure what your question is asking. If 2x,
So what do you do with the 2x?
so you say, so the two scenarios are, if this term x is 0, this whole expression is true. Agreed?
Yeah.
So one solution is x equals 0. Does everyone get that? The other scenario has to be if this binomial 2x plus 5 is equal to 0. If that's equal to 0, then whatever the value of x is, it doesn't matter. This expression is still going to be 0. Okay? So if this expression is equal to 0, it doesn't matter what this is. Okay? X doesn't have to be 0, but it'll still satisfy. So you need to check. When x is equal to 0, this whole expression is 0. When 2x plus 5 is equal to 0, the whole expression is still 0. Okay? So 2x plus 5, that's how we set this equal to 0. To check what the value of x is to make this expression 0. Okay, so 2x plus 5 is 0. 2x, 5 moves over, is negative 5. X is equal to negative 5 divided by 2. Okay, so when x is either 0 or this expression is going to be 0. Okay? And to verify that, you'd plug it in. I plugged in the 0 already. Now if I plug in the negative 5 over 2, so I'm going to have 2 negative 5 over 2 squared. So we want to check, sorry, this is left side and this is right side. So we're going to do this on your calculator, but we're going to get 2 times 25 over 4 minus 25. 0. Okay, so 25 over 2 minus 25 over 2 is 0, which is the same as the right side. So both my answers are correct. Okay? You guys got a question over there? Connor? Question here? No? Can we move on? Okay, you can't have a separate conversation though, guys. Sorry. Okay, last one, C. 6x squared minus x is equal to 15. So we could address this 15 being on the opposite side by moving it over, right? Because to factor this, we need to do that, right? We want all of our expressions on the left-hand side. And set it equal to 0. Now, because this is the coefficient is 6, we can't go to 2 sets of brackets. Okay, we have to use decomposition. All right, so we're still going to do M and A in this case, but we need to use decomposition. So M is going to be 6 times negative 15. So what is that? Negative 90. And A is negative 1. Okay, some of you guys might see this right away. You divide this by 9, get negative 10. So those are the two numbers. Okay, could have gone down the line, but pretty straightforward. So we have 6x squared. We're going to decompose this negative x into negative 10x and plus x minus 15. Okay, now we're going to partial factor. So is there a question there?
Plus 9x.
Yeah.
Oh, sorry, my bad. Yes, thank you. Plus 9x and minus 10 makes negative x. Okay, so this term is broken down into these two terms. All right, once we've done that, now we're looking for what's common between 6 and 10. It's going to be 2x. And what's common between 9 and 15 is 3. Okay, now I have two binomials that are common. So I'm going to bring that up here, 3x minus 5. And factoring it out of each, I'm left with 2x plus 3. Any questions there? So now we can't tell just by looking straight at it what the x-intercepts are, the zeros or the roots or the solutions, whatever you want to use as a synonym. But we need to set this equal to 0 and this equal to 0. So we set 3x minus 5 is equal to 0. We're going to get 3x is equal to 5 x is equal to 5/3. And then we're going to say 2x plus 3 is equal to 0, because all this is equal to 0, right? 2x equal to negative 3x is equal to negative 3/2. Any questions there? Now you take each one of these values and plug into the original equation and make sure you get 15. So on the left-hand side, I wouldn't even plug it into this equation because you could have done that first step wrong. You could have made this positive 15 for some reason. So you want to plug all the way into the original. So if we do that, we're going to look at our left-hand side first. So we're going to take 5/3 and plug it into the left-hand side. So 6, 5/3 squared minus 5/3. Okay, and we want to make sure that it equals the right-hand side, which is 15. So we have 6, 25/9 minus 5/3. 6 goes into 9, so you can put 3 into each of these. So you have 2/3 that's right. We get 50/3. 50/3 minus 5/3. And this is easier if you guys just use your calculator, if you can't follow the fractions. But we end up with 45/3, which is 15. Okay? At this point, you could have used your calculator though. Okay, I'm just doing it on the board in fractions. So we got 15 and 15, right? So that works. Now I want to check negative 3/2. So I'm going to plug that into the left-hand side. So left-hand side here. Again, we have 6x squared, so 6 negative 3/2 squared minus negative 3/2. And I want to see if this is 15. So we get 6, 9/4 plus 3/2, which is 3. Okay? 15 is left-hand side, 15 is right-hand side. Any questions? No? Okay, so that's solving quadratics. That's finding the roots and then verifying. Example 2, we're going to go into the word problems quickly. Andrew, can you read 276? Example 2.
The path of the stone thrown into a ravine is modeled by the quadratic relation y equals negative x squared plus 5x plus 84, where x represents the distance in meters traveled horizontally, and y represents the height in meters above the surface of the river at the bottom of the ravine. How far does the stone travel horizontally before it hits the water?
All right, so we want to know if we're throwing off a cliff, we're going to have this sort of projection, right? Okay, where this is our y-axis and this is our x-axis. So they're both in units of measure, distance, sorry. So we have our height, and we have our distance from the y-axis. And it's asking us, how far is it going to be from the cliff edge, distance in x? Okay? What is the y distance going to be, or what's the y value going to be right here? Jonathan, what do you think? So what's the height? Sorry?
The y,
Yeah.
or the x's you just marked?
Yes. Yeah, it's going to be 0. So what they're asking for then basically is what the height is going to, what the distance x is going to be when the y value is 0, right? Because they're saying how far from the edge is the distance going to be when it hits the water. So when the height is 0. So in other words, they're saying y is equal to 0, and you tell us what x is. So we're back to the same scenario where we have a quadratic equation equal to 0. We need to factor it so we can find out what the two x-intercepts are. Okay, or in this case, the positive x-intercept is going to tell us really, right? -1 won't exist in this case unless he's going behind it, but it tells us he's not. All right, so we need to factor this. So what's the first step? So I'm going to leave 0 here. I'll move 0 to the other side because we're used to looking at it like this. So we'll leave 0 on that side. What's the first step I got to do here? Daniel?
You have to get rid of the negative.
Okay, good. So how do I do that?
You put it outside
Yeah?
and then bracket
Yeah?
x squared
Good?
plus minus 5x.
Good?
And then you can close the bracket and put that on
No, you're completing the square.
well, minus 84.
Good, okay. So remember, we're back to just factoring at this point, so don't go back to 6.1. We're just asked to factor. Okay, keep going, Daniel. So that's good. My negative is on the outside. How do I factor this? Can I go to this right away? Can I do that?
Yeah.
Yeah,
Why?
because it's a square and you can do it for 84.
Sorry?
Like, because x squared, you can bring it down.
No, that's not why. It's because I can do this because there's no a value here, okay? In other words, the a value is 1, okay? That's why I can go straight to here. So I just need two numbers, though, in this case, m and a. What are the two numbers I need? Multiply to what, Daniel?
-5.
All right, so any idea how to get these numbers, Daniel?
You have to just try different numbers.
Okay, so how could we start that trial and error process? Remember the method I taught?
84 divided by 1.
Okay,
Continue from
is what? 84 divided by 1 is what?
there. 42.
No, divided by 1.
Oh, okay, negative 84.
Yeah, negative 84. Can I use these two to make this number?
No.
No. So I got to divide by 2, which is 42. Can I use these two to make this number?
No.
Okay. Divide by 3 is an uneven number. Or no, it's not. What is it? It's 84 divided by 3, somebody? Sorry? 28. Okay, still doesn't work. Divide by 4 is what?
21. No, yeah.
Yeah.
21. Okay, someone is yelling out 7. What's 84 divided by 7? Negative 12. Can I use these two, Daniel, to make negative 5?
Yeah.
Right? Positive 7 and negative 12? So those are our numbers, right? X, positive 7, x minus 12. You get that? You understand that? Yeah? Any questions? Okay, it was a little difficult, right? A little hard, but we have a process, okay? That's the key thing. It's not, I don't want to go just based off the people who have the best mental math. I want there to be a process that you guys can follow and always get it every time. Okay, so it did take a little while. You had to go all the way down to 7, but we got it. Now, the last step is I need to set both of these equal to 0. I can get rid of this negative sign. Why? Because I'm going to divide both sides by negative 1. If I do that, divide by negative 1, divide by negative 1, these negatives cross out, and 0 divided by negative 1 is still 0. So I get this expression. It's equal to 0. Okay, that's why the negative 1 can go away. Because we're setting an equality equal to 0, so an equation equal to 0. So now we have this is equal, x plus 7 is equal to 0, x is equal to negative 7, and x minus 12 is equal to 0, x is equal to 12. And which one's going to be your final answer? Ace, which one do you want to use? X equals negative 7 or x equals 12? They're both solutions to this answer. Okay, why 12? Right, because you don't have a negative distance here, right? So basically that's what this is saying, that x value could be negative 7, so behind him, 7 meters, or in front of him. We know he's throwing the rock forward, so we know we're dealing with x is equal to 12. Right, so the answer would be the stone traveled 12 meters before hitting the water. Okay, the last example here, example 3. I'm not going to go through it, it's going to take a little long. We don't have the time. I'm just going to explain it. So we're given 2 dimensions of a rectangle, and we're also given the area. So they tell us that these are the dimensions, and this is the area, the total area. Okay, it says, what are its dimensions? So in other words, it's asking for what is x, right? Because if we know x, we can figure out the dimensions. Okay, x is the only unknown. So we know the formula for area is length times width, so we would just do that. 3x plus 1 times 2x minus 5 is equal to 1150. Okay, this is the formula for area, right? Length times width is equal to area. So I've subbed in those values. Length and width is equal to the area. Okay. Once you have that, you're going to FOIL this term, combine this term with it. Okay, so when you FOIL this, you're going to get a C value, right? Which is going to be -5, looks like. You're going to combine this term into it and set it equal to 0. And then refactor, so you'd have 2 brackets again. But this time they would incorporate this area value. And then set them equal to 0 and solve for x. Okay, and you can see that solution on 277 there. Any questions? All right, stop it.